Okay. So this is what we discussed, right? We had different types of database, but but 1970s when Cord from IBM, he came up with the concept of relational database, and companies like Oracle, Microsoft, IBM, they developed RDBMS. And today, RDBMS is the most widely used database. That's why, okay, we focus on RDBMS. And out of RDBMS, we chose MySQL because MySQL is free in the sense it's a it's a open source, right? So, and also most of the web-based applications, they choose MySQL. Okay, so that's why we'll be working with MySQL. And okay, codes will be discussed, right? That it should be stored as data in table. Each value should be accessible. Value we should not duplicate so that editing becomes easy. Okay, we spoke about OLTP, OLAP. OLTP is where your system is directly is connected, live connected to any applications, and as you move along application, as you play with applications, the database changes, right? So like we talk about Amazon, and as we connect with Amazon, all our information is recorded, not recorded. We can also look back and read the information. So most of the activities that we do here online is is edit, right? And very few, maybe 30% is read, 70% is edit, and that's where the way OLTP is designed is little different than OLAP. OLAP, you don't do edit, right? 99% time you will do read, and OLAP is what we do as part of analysis, analytics, and data science, and all those things. So for now, for next few days, we'll focus on OLTP. When you say learning SQL, this is what we do generally. No, OLTP database is what generally we assume. Okay, when we do analytics, then we prefer OLAP. Sometimes when your data is too complex, in the sense your data is in 10 different tables, we sometimes join together in OLAP. Okay, because anyway, the what data that we download for OLAP is something which has already been done, used. Okay, and the users whose data we have, they don't need access to OLAP. OLAP access is given only to those who are working with the database. Okay, it could be data scientists, it could be data analysts. So they will be working with the data. So you can slice and dice. That's the word that we use in data warehousing. You can actually do that. Okay. It's anyway, it's a subset of OLTP database which no longer customer would connect. So you can edit it, making sure that your reading is done faster. Now, how reading is done faster, we will get to know when we actually start implementing or writing our code, right? So once we learn SQL code, I'll come back again, and I'll tell you the difference between OLTP and OLAP. Okay, so back of your mind, it's not something that you will speak in interview or write in the exam, but back of your mind, you associate OLTP with notebook, right? When you have a notebook, and OLAP with textbook, right? So when you want to just read something, OLAP is like your book, textbook. And OLTP is like notebook where you have to constantly edit. Okay. You take a notebook to a class and then you make notes. Tomorrow again, they tell you something else. And again, you have to make the changes in the notebook. So constantly you make changes in the notebook. And if you do not maintain well, after some time, what happens? Your notebook becomes dirty, isn't it? If you don't do it well, your notebook becomes dirty and it becomes sometimes difficult to read, right? Same concept happens with OLTP because when you keep logging in, keep editing, okay, so we spoke about primary key, right? We spoke about index, concept of index. And we said that index is what is used to get access to the data. Now, in textbook, your index is fixed, right? Because you don't edit. So, once you have written, your textbook is printed, you have index and there is no change. But in notebook, let's say if you have to have same kind of concept because it is important. Okay, let's say you have a notebook where you use single notebook for all the subjects, let's say, and all the topics, let's say, right? You don't know which topic is where. So you probably prepare an index on day one and say, okay, these are the topics available right now. Next day, again, you make some edit in the notebook. Again, you have to update your index, isn't it? Because the second concept that you have added, second day things, is not getting reflected in your index. So you go back and again make the changes in the index. If you don't do it, then what happens? It becomes difficult for you to search for your own content, right? You don't remember after, let's say, 6 months when you have to appear for an exam or you want to prepare for an interview. Okay, you open your notes and you don't know which topic is where, right? So you need to maintain that index. Now, this is the challenge in OLTP because you keep editing, your index will be changed. And after some times, the index, if you do not recreate index every day, right? Let's say, for first 5 days, you are maintaining the index very well in notebook. And then you feel, then you stop updating index. After 20 days, the index that you have, which you created in the last fifth day, becomes invalid, right? Because you got a lot more information, a lot more stuff in your notebook than the fifth day. So the index that you created on the fifth day is as good as not having an index. So when you don't have an index, searching becomes slow, very slow, right? Same thing happens with the OLTP. When you keep editing every day, okay, so your index becomes invalid. So there are a lot of other things as well. So what happens generally, when you see that system is down for maintenance, right? You will hear the system is down for maintenance, mostly on the weekends or in the around midnight range, because that's when you'll have less people connecting to your database. So they upgrade the database. They upgrade, sorry, that's not the right word. They um, um, they recreate these indexes, okay, because of the users logging in and out and keeping updating all those data. The index becomes invalid and system starts becoming slow. So you recreate, we call them as nightly jobs generally, they recreate all the indexes. So as frequently as possible, they keep recreating these new indexes, okay, so that it becomes, your system performance improves, okay. So yes, OLTP, the maintenance is important, because if you do not maintain it, it becomes slow. So sometimes, these days what happens, you'll have two databases, primary and secondary. Your application will be connected to primary database, and secondary database also has a connection, but secondary database will be connected when primary goes offline. Okay, that means if some problem is with the database, okay, that's when it will switch back to secondary. And primary and secondary are maintained at same information. So whatever, so there's a connection between primary and secondary too. So let's say you're working with Amazon database. Amazon is connected to database one, let's say. And the backend, everything that is happening in DB1, database one, is also getting reflected in DB2. So DB2, the secondary database, will always be synced with DB1, the primary database. Okay. So whatever is the primary database, same stuff will be in secondary database. So just in case, let's say primary database connection goes off, connection goes down, you switch automatically. These days we have auto switching. So your application will automatically switch to DB2 as the secondary DB. And secondary DB, since it has all the information of the primary DB, your application is still running without any problem, right? So for as a user, end user, you will not even know that there is a switching that has happened in the backend. Okay, that no longer connected to DB1, DB2, because DB2 has all the information, exactly replica of primary DB1. Okay, it has an exact replica, so everything is there. So then the team would go and fix primary DB and restore it, and then again, make sure that primary DB is again exact replica, because you would be adding few more stuff on secondary DB, which primary DB is not aware of because it's under maintenance. So once maintenance is done, they'll bring it up to speed with secondary DB and then again switch you back to the primary DB. Okay, so this is what happens in the backend. And then, so even if you have to maintain the DB, right? Switch on, move to secondary DB, recreate all the indexes, and again put it back to the primary DB. Now, secondary DB again you recreate while it is connected to primary DB. But there's a risk there, okay, when you're doing maintenance. Okay, you have two DBs right now, okay, not in maintenance. So you can switch to secondary DB to primary DB. But let's say if you are already connected to secondary DB and primary DB is under repair, and then something wrong happens with secondary DB, your application will stop. So that's why sometimes, you'll hear that application is not connected, or, application is down. Facebook gets down, you'll hear those kind of things. Gmail is down is because both primary and secondary probably got affected at the same time. So there's no third. Generally, we don't have third. But yes, if it's a mission critical kind of application, when you talk about launching of rockets and things like that, they will have multiple mechanism, right? They'll not just depend on two databases, but they have three or four. Okay, so it depends upon how critical is your business, right? Maybe if you are running your own website for fun, probably you may not even have secondary DB, right? You're okay with primary DB. But if you are using a application, you're running a business, you'd want at least secondary DB, right? So that's how it happens. Okay, the OLTP you need to maintain that kind of structure. But OLAP we don't have to maintain that kind of structure, because OLAP you'll have only one or two people connected, or maybe at max 100 people connecting to it, not thousands. Okay, you have only data analyst connecting to your OLAP, getting the data, and if something goes wrong, okay, because you're not allowed to edit anyways, right? Something goes wrong, you can always wait for some time, right? It's not as mission critical as your customer using your database. So there are logically and physically some differences between OLTP and OLAP, but right now our focus is on OLTP, right? We'll see how OLTP is done. Then we started coming closer to the hands-on. So we spoke about DB server. When we install MySQL, what MySQL does is you get DB server installed. So you have DB server installed, and you can have multiple databases installed in one server. Okay, so when when you have multiple database in one server, okay, these database, if required, okay, not always you do, because you create two different databases for two different purposes, so there's no need to connect them. But if required, you can connect, okay, you can use them. But if you have a different server, okay, there's no way you can directly connect, even though it is same MySQL or Oracle. There's no way to connect them. So you have to go through what we say the the third party kind of thing. Even though they are MySQL, you need to you need to perform import export. Okay, so from one DB server database, you say export and import, and we are not getting get into those things because those are your admin jobs. Okay, so you'll ask database administrator to get data from other database also. Let's say you are working on OLAP application, and you need two data which are two different databases. So you'll ask your um, admin to give you the data from two databases, and then you can put them together later. So that's job of admin. We are not getting into that. So you have multiple databases installed, and how do you connect to each of these databases? So you need to know which machine has this server, right? Server would be hosted on certain machine, right? So if it is on your local machine, you can use local host. Okay, and first we'll first next few days we'll focus on connecting working directly at from Workbench in MySQL, right? So hopefully you can see Workbench installed on your machine. So we'll connect through Workbench, we'll learn all those things, and then we will see how to connect from Python as well. Okay, so last class of our database will be accessing the databases through Python. Okay, so for now, to connect to any database, whether you're connecting through Python or you're connecting through Workbench, you need these four information: your host name, where the server is installed, the database name to which you are trying to connect to, username and password. Okay, so these are the four minimum things. And when you log in as a root password, okay, so root is the admin password for MySQL. So everybody, like my SQL server has SA, system admin SA. Oracle has sysadmin, right? So all these are system administrator password, and that will be only one. Okay, and with that password, you can do anything with the database. And if you lose that password, there's no way to recover it. So there will be one system administrator who will have that password, and of course, you don't forget that password. It's very critical for your database. And what they will do, they'll create multiple users. So so you don't want to share your sysadmin password with everybody. You cannot. You should not. You create, so that's called user management. Okay, so you're creating multiple users. You can give them access permissions. Okay, and they will perform the roles that you have given. Let's say I want to connect to database, but I just need to read some data. So system admin will create a username, okay, called user1, and say user1 has access to just one table, and that too um, select and update. Okay, so that's a part of user management. And since we are we are working for our learning purpose, so you can continue to use root password, no, not a problem. But in real situation, you will never ever have the SA password, okay, or the root password. They will never even share with you. They will give you a username password created specially for you based on your requirement. Okay, so with that, okay, so this is the different options that we perform. CRUD applications. CRUD is, so when you say SQL, mostly this is what we focus on: how to insert data, how to select data from the table, update and delete. Okay, this is the role of developer. Architect role is how to create tables, right? So before that, you need to know how many tables to create, what should be um, their structure, right? What all columns should we add? What are different data types, okay, that a column will take? I showed you, I gave you a link also, right, for the data type in MySQL. I'm going to give you more links, okay, as we go along. Okay, so that's for you to practice on yourself. So practice by yourself, right, on MySQL. So you connect many columns, okay, how many column, what should be the structure, and this is critical. Okay, you do not want to change the database table continuously. What happens? You have a people working with, let's say, Python applications, Java applications, other applications like HTML applications, and they will be connecting to your database. Right? They have already written a code. Let's say, Python have written a code, select star from table one. Right? So that means that I'm assuming there's a table called table one. I'm getting everything from the table one. But in the backend, now you change table 1 to table 1.1. If you change the table name to 1.1, all the applications that are getting connected will start failing, right? So changing database structure is done very rarely. Do not want to do that because it will have implications on the on the applications which are connecting to it. So that's why it is critical that you involve some experienced person who understands the business and can tell you database where very minimal. It's not that totally no, you can't perform any changes. You should be able to perform some changes in the future, but very minimal. Okay, so that there is very less or no impact on the code that is already been written for the database. So that's the role of architect. They create what is called as, okay, so yeah, these are data types, right? They create what is called as ER diagram. So to understand ER diagram, we need to understand what are relationships in database, right? One to one, one to many to one is same, and then many to many, right? So we said that if there is one to one relation, put them in one single. All the attributes which have one to one relationship will be in one table. And when you have one to many, okay, or many to one, the way you look at it, we need to create the foreign key relationship. Okay, so the foreign key relationship we have to create so that two tables are linked or two tables are related. That's why we say relational database. This relationship is important because without relationship, you won't be able to access all the information. So you are missing or you are violating the CORDS rule. CORDS rule says that every data has to be accessible and every data should be connected directly or indirectly. Okay, so this is where relationships comes into picture. Okay, two table. Okay, if they are one to many relationship, you connect them using foreign key, right? So we discussed about like employee and department, right? Department will have multiple employees, but one employee will belong to only one department. So that's where you'll have many to many relationships. So what we do in employee table, we create an extra column, which is a foreign key. And this extra column will connect to the primary key of department. Okay, it is foreign key is has to be the primary key in another table. Okay, it has to be the primary key in another table. So you have a foreign key connected to the primary. A foreign key in employee is connected to the primary key of department. That's how your employees and department tables are linked. Then you have many-to-many relationships. Okay, so multiple values from both the sides. So we spoke about students and subjects. We said that, okay, one student can have multiple subjects, and multiple subjects is associated with one student. At the same time, one subject will also be associated with multiple students. So we actually represent, let me show you this one second. We actually represent this relationship with set diagram. Okay, so let's say you have first case. Okay, you have second case, and this is now third case. Okay, so here, let's say you have employee name, and you have phone number. So one employee will have one phone number. This is what we call as one-to-one relationship. One-to-many is, yeah, you have employee here, right? Employee name, and let's say department. So let's say this is department one. Department one will have multiple employees, right? Department two will again have multiple employees, right? This is what we say one. So we say one name, one phone number, one-to-one. Okay, here one employee, right? In fact, D is one department, and many employees. So we say many-to-one relationship, right? Now here you have student and let's say subject. Okay, so one student, let's say this student will study this subject, will study another subject, will study another subject, right? Same way, okay, this subject, okay, now this subject will be studied by that student plus one more student plus one more student, right? So that's why we say many student will study many subjects, right? So this becomes your many to many relationship, right? One to one, many to one, and many to many. Make sense?
Yes, sir.
Yeah. So this is what we say relationship, and this is the key of any relational database, obviously, because we're talking about relationships. Okay. Then, okay, so we took this example, employee ID. So we had to add DID. DID is not required, but we had to add DID to connect this employees to department here. Okay, then you have student and subject. So we had to create this new table to link student and subject. So this is example of many-to-many relationship. Okay, so I told you what ER diagram. ER diagram will have three different, it will have four information. One, it'll have the rectangle boxes, which talks about the entity, right? So here you have student and courses. Then second thing is entity, and then is our relationship. So every sorry, every entity will have relationship with other entity. Okay, it see not as like student and subject may or may not have. Okay, but if student and courses are connected, then you have a relationship. It says that student joins a course, right? So student joins a course. So entity relationship, then you have attributes. Attributes become columns. Entity becomes table. Entity becomes tables. Attributes becomes column for the table. So your oval shapes that you see, those are the columns for the table student. We call them attributes, entity, relationship. Okay, and the next thing you would also they'll talk about is a relationship. Okay, so here in this diagram, relationship is not shown, but here diagram will also show the relationship. Okay, is it one-to-one, one-to-many, and or many-to-many? It will not show you the solved one, right? It will show you many-to-many. But when you convert into table, that's when you need to know that you have to create a relationship will become a table, right? For example, course and subject here, has will become a entire, has will become an entity, okay? And then you talk about primary key. Primary key, every table will have it. You should have primary key. That's when it makes easier to search and update. Because if you remember Cord's rule, what Cord's rule says was every cell value, every cell has to be accessible using three things. Do you remember what was the three things that it mentioned? First thing it mentioned was the table name. You should know that particular cell is in which table. I want to know phone number of an employee. Phone number is in department table. So table department is the table name. So you need to know the table name. Second thing we said was primary key. I need to know the phone number of Sachin. So I need to know what is the employee ID of Sachin. Otherwise, I can't access. So primary key, table name, then primary key, then the column name. Which column has phone number? Is it called phone number or the employee phone number or phone number home? Whatever. The column could be, something different. So you need to know the table name, you need to know the primary key, and you need to know the column name. Using these three things, you should be able to access all the data. So every table you should have primary key, and if there is relationship between them, okay, in ER diagram, it can be one to one, one to one, one to many, or many to many. Okay. But when you start developing it, okay, you will not be putting many to many. Okay. You'll be creating a new table and, breaking that many to many into one to many and many to one and one to many. Okay. That's the purpose of the many to many relationship. Okay. So this is assignment which I had given you. I'm sure you must have done it. Okay. So this is where you need to download your MySQL, or you can do Postgres. Postgres is also now getting popular, but yeah, still MySQL is best. So we will stick with MySQL. Okay. So these are the things which I'll give you for your reference, but you don't have to, okay, go through this because we are going to perform all these things in the class. So maybe what I'll do is I'll remove this. I don't need to have all this. Wait. Okay. Um, okay. So I have both Postgres as well as MySQL. Okay. So if you log in with MySQL, you will see a Workbench, right? MySQL Workbench. MySQL Workbench is the UI tool through which you can connect to your database. So you click on MySQL, and while it is getting launched, okay, yeah, this is the MySQL Workbench. Okay. And okay, so depending upon what you use, you can use user one, okay, or you can go with root password, root user. So let me go with root user and password. Okay, it'll ask me the root password. Okay, and if you forget this, then you can't access it. So remember that password. Okay, now here I have created 1, 2, 3, 4, 5, 6 tables, right? Six databases, not tables, these are databases. Sys, World, Sequila, these would be installed by default. Okay, and Advent, Library, and Student DB, I've done, I've installed myself. Okay, so this is my MySQL Workbench. Similarly, if you are doing Postgres, you will see PG admin. Okay, Postgres will have okay, so instead of searching, let me go directly. P, okay, OP, right? Postgres, okay? Postgres, and if you scroll down, you see PG admin, okay? So PG admin is like Workbench of MySQL. So again, it'll open, and with admin username and password, we should be able to log in to the entire database. We can see all the databases here. And all of them will have editors, SQL editors, where you write your SQL queries. Okay. So the SQL queries that we're going to learn, you're going to type it and write it there here. Okay. While it comes up, let's go back. So, okay, I've got a lot of databases, which probably I don't need anymore. I can drop it. Okay. So how will I drop it? Let PG admin come. Okay. Meanwhile, we'll come here. Okay. So this is your SQL editor. Like generally, if it is not there, you can go to right click or you can create here. You see SQL, you can click on plus SQL, this first icon. This will create that. Now I need to drop, I don't need Advanced DB. So what I'll do, okay, I will say here, drop database, okay, and it'll also suggest you, okay. So drop database, okay, database name, ADVAITDB, okay, semicolon, okay. Semicolon indicates end of line, okay, so end of command. So SQL queries are single line command, okay. Stored procedure are like your Python program where you can write multiple lines like functions, but SQL are one line. That's why it is challenging also to learn, right? Within one line, you can do a lot of things. So drop, I'll click on this run. So see, green tick means that my query has run successfully. Now you see, the database is not there. Now let's say I drop student DB as well. So one way is you need to remember drop database, that's a SQL command. Drop what? Drop is to delete, right? So drop what? You want to drop a table or want to drop a database? I want to drop a database. So I'll say drop database and database name. Or you can simply right click here and say alter schema, drop schema. Alter schema is where you want to make some changes to it, and drop is to totally delete it. Drop, because since this is something which you cannot roll back. Once it's gone, right? So it'll ask you, do you want to, it's giving you a time to think, do you really want to do it? Or think, or you really want to do it? I say, I really want to do it. Gone. Student is also gone, right? So this is how you drop. Now, if you want to create a database, so we can create database by by command, okay, or by okay by manually here. You see the plus sign creates a new schema, right? You can say plus and you can give the schema name, okay, or what I'll do, I'll close, I can give a schema name here, okay. So or I'll close it, do not save, and I'll do it through query, okay. Using UI it's easy, right? But we will see using query how to do that. I'm going to say create. Now see, SQL commands are case insensitive. So here I wrote all caps, and here I'm writing capitals and small. I mean, I'm doing mix cases. It doesn't matter, okay. SQL commands are case insensitive. So I say create database, whatever you feel comfortable, you use it, but don't use it capital and mix, okay. Whatever you feel comfortable, you use it, follow the same standard, okay. I did it just to show you that both are same, but this is not recommended. You follow a single standard, okay, so that it'll look good when you save the query or when you show the query, right? It doesn't look good, right? Once you have capital, once you have small. Okay, so coming back to this, say create database, and I'll say here employees database, okay, employees. Now, if I run it, what will happen? You know what? So now you have two queries, right? Now I don't want to run all the queries, so I'll select and then I'll say play power button. Okay, it created database employees, and okay, you go to schema and or you go here and say refresh all. So you see the employees is created. Now schema name by default is all lowercase. So even though I give capital here, schema names are generally lowercase. This is how you write comment. Comment is something which is not read by your program, by your by your software. Okay. So in Python, how do we give a command? Comment.
Hash symbol.
Hash, right. So we give hash to indicate it's a comment. In C plus Java, we have double slash. Okay. Here we give double hyphen. So I'll say schema name or DB name has to be all small. So even if you give capital, it'll convert into small. Okay. So you will never see schema name. So what happened, you will talk about um, what is the difference between schema and database. Okay. Now every every um, um, databases, they have own way of defining this. Okay. In Oracle, the schema concept comes from Oracle database. Oracle, what they did was they'll say, okay, we will have one database, and in that database you can have multiple schemas. Inside database you can have multiple schemas, and your tables are grouped in schemas. Okay, so it's a grouping of tables. So you have database, within that you have schemas, and the tables, when you create, you have to add it to a particular schema. Okay, so that is a grouping to show that, okay, schema 1 has all user related table, schema 2 has all sales related table. Okay, and since they are into same database, there is you can have absolute seamless movement of data, and you can even have username and password at schema level. So you can lock at schema level that, let's say for employee will not have access to finance and HR data. So HR schema and finance schema will have password, and you will not have access to that. Okay. So sometimes so it was also used to control the data. But in MySQL, schema and database are same. So we generally call it a schema. We don't call it a database. We call it as schema, but it is same as database. Okay. So the way we treat it is like database only. Okay. So that's why we say schemas here, but these are your database. Here you don't have the concept. So it's like server is one database, and you have multiple schemas within that. So, it is like a database itself, because when we create a table, you have to tell which database you want to connect to or which schema you want to connect to, right? Okay. So this is how you create or drop a database. So we have database ready. Now, next step I have to do is, what do you want to do next? Tell me.
Put data in the database.
Put data in the database, but data will go as a table, right? Table
Yeah.
is, table is something that will
Of which you
host
create a
your,
table first.
right,
Okay.
right. So table will have your database, right? Okay. So now before you, get into table, we need to have that ER diagram in our mind, right? Which ER diagram you want to implement. Okay. So let's say you want to implement, this is employee, right? So let's create employee ER diagram. Okay. So quickly, okay. Um, let's plan which all tables you want to create. So we will have employees table, we have department table. Okay, so I'm going to say tables that we want to create. Tables, employees, department, and then what else? Tell me one many to many table. Employees, many, say location, let's say. No, location also, employee will have only one location, right? What will employees will have many?
Co-workers.
But co-workers will be in the same table, right? It's
Mm-hmm.
part of your employee itself. So let's say department, department and location, let's say. A department can spread over multiple locations, isn't it? Okay. So we'll say location. Now location will have city and maybe some column that we'll add. And then you need to create another table to maintain the relationship between department locations. I'll call it as department location. Okay. So employees, double ES, departments. Okay, generally table names will have plural form. Okay. Okay, so let's create these 4 tables for now. Now you tell me employees and department will be connected using foreign key, correct? So out of these, which table will be created first? Out of these 4 tables, or let's take 2 by 2, two at a time. Between employees and department, which will be created first? Which one should you create first?
The one with the primary key. So
So every
employees
table
probably.
has a primary key.
Mm-hmm.
We discussed that, right? Every
Yes, sir.
every table will have a primary key. Now you see, employee has a foreign key, right? So now foreign key should be related to department. So without creating department, how can you create a table? Okay. So choose first, you have to choose the table which will not have any foreign key. So in this case, department will not have any foreign key. Locations will not have any foreign key. So locations and departments can be created first. Okay. So you can create location first or department first. So definitely 1 and 2 is department or location. Now 3 can be employees if department is created, and 4 can be this one because department needs both departments and location to be created. That's how you will link it. Otherwise you can't link it. Right? Okay. So we need to create either department first or location first, not other 2. Employees or this will not be there. So let's create quickly at least 2 tables today before we wrap up. So I say create table. This is the command, create table. Okay. Creating table command. Look at this. Create table, table name. So departments. Bracket open, bracket close, semicolon. Okay. Now within this bracket, you need to mention the columns that it needs to have. Column 1, let's say department ID. I say DID. Now DID, okay, should have a data type. Okay. So what data type should it have? Right? Let me take you to the notes here once. Give me a second. MySQL, or let me do it here in front of you. Where is this file? Hold on. Oh, entire this was selected. Okay, so here you can say I didn't have to reshare it, right? It was all shared before. So what was that? MySQL data types. Okay. At basic level, you have those data types only, right? But then you see in detail, you have character, varchar size, okay, tiny text. These are your text data. Then numeric data, you have boolean, int, right? Int also you can give size, okay. So these are your data types, date, okay. So text, date, bool, all these are there. So I'm going to copy this and save it here. Okay. So I'll say refer data types for MySQL. There will be minor difference between each of these, okay? Minor, very minor, okay? Almost like 99.99% is same. So I think our PG admin is now ready. So I'll show you how PG admin also looks like. Okay. Let me go ahead and share the entire stuff. So you have this. Okay. So this is PG admin. See, these are the servers. Okay. And now I'm trying to expand my profile DB. It is asking me to enter the password. Okay. Otherwise, I will not have access to database. So I think the password here is learn@123. Okay. Now you see, these are the database here. My profile DB has two databases. It has my profile database and Postgres database. Okay. We'll talk about login setup maybe in the next session. So you have profile DB and Postgres DB. These are two databases that are there. If you expand my profile DB and go to public, and if you scroll down public, you have tables here. So see, there are three tables here: details, testimonial, and users. Okay. And if you go to Postgres and public and tables, it has a new table. Okay. So this is very much like Workbench. Okay. I'm going to close it. And now we will move to our MySQL. Okay. Same, we can do. Yeah.
Sir, I have a quick question. So
Mhm.
when we're dealing with like MySQL or Oracle or Postgres, different softwares, do the queries have to be formatted in different ways
No,
for
that's
the
what I
software?
told you. 99.99% no.
Uh,
Okay. So doesn't matter what your database is. No, standard for SQL is given by a body called as ANSI, American National Standard for some standard interpretation or something. Okay. ANSI. Okay. I'm not sure about the full form. You can actually check. ANSI sets the standard for SQL. And all these companies will have to implement those standards. Okay. So where that 0.1% difference comes is that, see, ANSI will tell you do this. I'll give you 5 assignments to do that. Let's say 5 assignments, you have to do it. Correct? But you can do more, right? Nobody's stopping you from doing more. So to compete against each other, see, ANSI is a standard which everybody has to follow. So if you do not follow, then you are not qualified, to sell your product in the market. Okay, whether it's Oracle or Microsoft or whoever it is. But in order to compete against themselves, right, they implement same thing in different ways. They add few more features. So when you are dealing with, let's say you do not have plans to switch to multiple databases. Let's say you want to stick to one database. Then you can go ahead and use these additional features of that database. Okay, let's say you want to say that, okay, I'm going to stick with MySQL only, and I'm not going to connect my application to any other database. So then you go down to the MySQL specific features that they have. Okay, but some people, some applications, they do not fix which database, right? Let's say small application. So if a company already has Oracle database, you can't force them to go with MySQL. Now, in that case, you have to make sure that you do not, you stick to the ANSI standard codes only. You do not make your application MySQL dependent or, Postgres dependent. So 99.99% SQL queries are same. Okay, so that's why it doesn't matter. There is some changes, a little bit, which you'll have to be careful about. Otherwise, absolutely no change. Okay, the query that I've written, drop database, or I'm writing create table, they are exactly same for both, or in the sense for all. Okay, database, all RDBMS, not any database. RDBMS follows SQL. Okay,
thank you, sir.
sure. Okay, so what we'll do is we'll quickly create one department table and we'll stop for today. So DID, I'll say integer, int. Okay, and I will make this as primary key. So you have to add primary key like this. Then comma, you say department name. Department name is varchar. And varchar will need to give size. So I'll say varchar 32. Okay, so maximum it can store is 32 characters. If you try to insert higher than 32, it will throw error. It will not accept, value more than 32, but it can accept less than 32. That's why I say variable characters, but maximum is 32. D name, department ID, say HOD, head of department, and you can say varchar 35. Okay. And we said about code, right? Let's say department code that you will use to file any expenses. So here, let's say I said 10. Okay. So create table name, simple bracket open and close. Within simple bracket open and close, you have to write three things: column name, data type, and if there's any constraint. We'll talk about constraint the next session. The column name, data type, and constraint. Primary key is a constraint. You can have other constraints also. Other constraints are not null. If I say not null, then you cannot leave dname empty, not null. Not null constraint means you cannot have empty dname. You can have duplicate department name, okay, but you cannot have empty. HOD, okay, I can say again not null. You can have check constraint. Check constraint means values that you give in check, well, those values should be there. Let's say you have location, for example. Location, you have only 4 location, let's say, across the globe. Okay, so you will say that the user who's going to enter the value in location should enter only one of those 4. So you can say check, okay, that give value within these 4 only. So if there's a 5th value, okay, it'll throw error. Okay, so those are different constraints we will see when we try to create other tables. Now you see here, if I expand employees, this is what we are creating, right? Tables, views, stored procedure, functions. Now if you click on tables, there is nothing because we have not created. Now when I select this and I run it, cross, that means there is an error here. No database selected. So there are 2 ways to do it. First, you say employees.department. Okay, so employees.department you can say, so that it knows, okay, employees department should go to employee database. We have so many databases. Which one should we get added to? Okay, so you can say create table employees.data department, or you can say use here, use employees. Now, when I say use employees, then for rest of the thing, if I do not mention the database, it will go to employees only. But if I mention it, it will go to the specific department. So you can use or. Now, the moment I say use or, and when I run it, okay, it's saying using employees. Okay. Now, even if I don't give employees to department, it will go to the employees department. Now go and click run. Tick, green tick. Green tick means successfully executed. Now you go and say refresh all. Okay, and see department table is created here. And columns, if you want to see, these are the columns here. See, DID, DName, HOD, D code, these are the columns. Indexes, primary key will have indexes for sure. So see, this is a primary key. Okay, by default, primary key will have an index. You can create index on any column. Okay, but if you want to create index on any other column other than primary key, you have to specifically write code. I want to create a index for HOD column. I can do that. Okay, I have to say create index and then have to define the values. But primary key, you don't have to. Automatically, it creates index for primary key. Foreign keys, this does not have any foreign key, so no foreign key. Okay, no trigger. We have not created any trigger. So now you see, this is how your table has been created. Okay, we'll stop here for today.